यूट्यूब में पहली बार एक नए स्टाइल से पढ़ते हैं केमिस्ट्री, प्रैक्टिकल ऑर्गेनिक केमिस्ट्री। समझिए जरा, वीडियो देखिए। तो गूगल मत करिए, रसायन प्रयोगशाला पे जुड़े रहिए। पूरा टाइट्रेशन क्या होता है आपको बताया जाएगा। वॉच टिल द वेरी एंड।
लेकिन है ना, मोटा मोटा बता देता हूँ, कुछ कुछ करके पानी का कलर पिंक करना होता है। तो मेरा ऑब्जेक्टिव क्लियर था कि रीडिंग मैं घर से याद करके जाऊंगा और वहां जुगाड़ लगा के पानी को पिंक कर दूंगा। तो रीडिंग मैंने घर से याद कर ली और पानी पिंक करने के लिए मैं रोबजा ले गया। तो टाइट्रेशन में क्या होता है ना, एक नीचे फ्लास्क होता है और उसके ऊपर ट्यूब होती है। तो वो पानी ना फ्लास्क में पिंक होना चाहिए। मैंने रोबजा डाल दिया उस ट्यूब में और वो रोबजा अंदर गया और जाके ऐसे नीचे बैठा हुआ है। तो वो इतना रोबजा दिख रहा है और इतना पानी दिख रहा है। अब मैं उस ट्यूब को हिला रहा हूँ।
प्लीज ये गुस्ताखी आप मत करना। पढ़ लेते हैं प्रैक्टिकल ऑर्गेनिक केमिस्ट्री का बहुत इंपॉर्टेंट टॉपिक, जिसमें से सवाल आएगा ही आएगा नीट और जेई में। तो इसकी जानकारी होनी ज़रूरी है। रोबजा से पिंक कलर प्लीज़ टाइट्रेशन में मत लेके आना यार। रसायन प्रयोगशाला को लाइक करिए, सब्सक्राइब करिए, वीडियो को सेव करिए और अपने दोस्तों के साथ शेयर करिए यार। अब पढ़ते हैं कॉन्सेप्ट। देखिए, जब एनालिसिस की बात होती है, दो टाइप के एनालिसिस पॉसिबल है, क्वालिटेटिव, क्वांटिटेटिव। क्वालिटेटिव बोले तो जहाँ पे क्वालिटी पता चलती है, कौन सा एलिमेंट प्रेजेंट है, कार्बन, नाइट्रोजन, ऑक्सीजन, फॉस्फोरस, सल्फर, कौन सा एलिमेंट प्रेजेंट है, या फिर कौन सा फंक्शनल ग्रुप प्रेजेंट है, क्या एल्डिहाइड है, कीटोन है। एनी ऑफ दिस इंफॉर्मेशन इज योर क्वालिटेटिव analysis, which is a part of organic chemistry GOC chapter, but now it is a separate chapter ऑल बाय इटसेल्फ। प्रैक्टिकल ऑर्गेनिक केमिस्ट्री आपका अलग से ऐड हो गया, जैसा कि आपको पता है। क्वांटिटेटिव में आती हैं दो चीज़ें। ग्रेविमेट्रिक आपके सिलेबस में नहीं है। टिट्रीमेट्रिक इज द टॉपिक ऑफ कॉन्वर्सेशन फॉर टुडे। टिट्रीमेट्रिक क्या है? एक तरीके की क्वांटिटेटिव एनालिसिस है, क्योंकि आपको क्वांटिटी पता लग सकती है एक पर्टिकुलर सॉल्यूशन की, है ना। हमारे केस में हम स्ट्रेंथ निकालेंगे या कॉन्सेंट्रेशन निकालेंगे, ठीक है। सो व्हाट इज अ कॉन्सेंट्रेशन टर्म? कॉन्सेंट्रेशन क्या होती है? फॉर एग्जाम्पल मैं स्ट्रेंथ की बात कर रही हूँ तो कितना ग्राम सॉल्यूट है 1 लीटर सॉल्वेंट में, है ना, ऐसा कह सकते हैं। सो दिस इज नथिंग बट क्वांटिटेटिव एनालिसिस। तो पहले तो आपको ये पता होना चाहिए कि टाइट्रेशन एक क्वांटिटेटिव एनालिसिस है। अब होता क्या है, इसमें ज़रूरत पड़ती है, पहला शब्द जो आपके सामने आता है वो है स्टैंडर्ड सॉल्यूशन। क्या होता है स्टैंडर्ड सॉल्यूशन? You must know that standard solution is a solution whose concentration we will be knowing. So when I'm saying standard solution, automatically there are certain characteristics of a standard solution that should strike the doors of your mind. For example, it should be non-hygroscopic, that should not absorb moisture. Second, it should be pure. There shouldn't be any impurities present, and if there are impurities, you should be able to remove it. I mean, you should be able to identify, okay, yeah, here is impurity, I need to remove it. Then it should be soluble in water, because generally the solvent that we shall be taking is water, right? Now that, having said that, you have understood that we're going to take some solid and put it in water. So solid that we are taking should be number one in pure state, that's there, should not have any impurities, that's there, but the molecular mass, the relative molecular mass should be high enough. Can you think of the reason? Certainly here comes the reduction of error thingy. We do not want errors. In titration, even a little bit of difference in the weight / mass will end up bringing huge errors in our titration. Okay? So we do not want that. It's better we take relative molecular masses high for our standard solution ka solid, so that there is no titration error that comes up. And last but not the least, see, what you're taking should be reactive with the analyte. That means standard solution is what? Something whose concentration we know, and the solutions whose concentration we know are titrant. Point to be noted, my lord, there's just a difference of T and D, so be very mindful when I'm saying titrant or titrend, right? So titrant when we are saying, then we take standard solution as our titrant, And usually we're going to take titrant in the conical flask and titrant, the analyte, in the burette. Okay, so we will see in our case what's going to happen. Got that? All right, now let's proceed with the process of what is this process of reacting a titrant with a titrant. What is this process? This exactly is your process of titration. But when we are saying titration, it's not just a reaction happening. It's a reaction that can be distinguishable from the naked eyes. You should be able to look at the reaction and tell that, okay, now the reaction has got completed. Now, in order to get that eureka moment that, hey, the reaction is complete, you understand, you need to have some physical change that is perceivable from your naked eyes, isn't it? So the process of adding standard solution to solution of unknown concentration, basically reacting the titrant with the titrant until reaction is just complete. Point to be noted, my lord, this line is very important. Until the reaction is just complete. How would I know reaction is complete? Either the moment reaction is getting complete, there is some dramatic change happening which is perceivable from the naked eyes. So we should be able to detect that end point. We should be able to detect that equivalence point. We'll understand the difference between equivalence point and end point in a bit, but right now understand them as one for now. Okay? So I'm saying equivalence point should be detectable. Either it is detectable on its own because the reaction only is showing some physical changes like color change or precipitation that is perceivable from our eyes, or you may add dash, fill the dash, indicator. So you may add indicator. What is an indicator? You understand, right? For example, if you're working in kitchen and you're making toast, the toast, when the moment the toast is ready in the toaster will show color changing from, let's say, red to green. That shows that, okay, now your toast is ready. The moment you are talking about your cell phone, let's say in the cell phone, the moment the battery thingy becomes red in color, that means it's an indication that the battery is less than 15%. Indicator. So indicators are those perceivable, distinguishable changes that can help us in understanding, okay, in this regard, that the reaction is complete. So equivalence point is the point at which the reaction is completed, and it is difficult in the practical chemistry to figure out this equivalence point. Because the perceivable change that I'm talking about, that's not going to come at equivalence point. That's going to come just one drop after the equivalence point. So equivalence point is generally called stoichiometric endpoint or theoretical endpoint, but it is not a practical endpoint. Practical endpoint is a little more than the equivalence point in terms of, if let's say at this very moment, let's say the reaction got completed, but I'm not able to distinguish it because the color is still, let's say, colorless. But one extra drop of now NaOH and a pink color appears, that's when I would say, oh yeah, reaction has got completed, because that's what my eyes can perceive, one single extra drop. So equivalence point is exactly the theoretical point when both are equal, but one extra point and we see a change, a perceivable change, a color change, for example, in the acid-base titration of an acid and NaOH using phenolphthalein as an indicator. So we are going to talk about that precisely. And रूअफ़ज़ा डाल के एंड पॉइंट नहीं निकालना है यार, इट्स वेरी विस्कस, वही होगा नीचे आकर, इट विल, एंड स्पेशली इन ब्यूरेट, हे nothing I can imagine, nothing. I was laughing like anything, so please, all my Rasayan Prayogshala students should not do that. Yeah? Chalo. Let's get started. How to detect endpoint. So you understood that we are going to be working with indicators, though when I'll be teaching you redox titration, we will be not needing indicator, because the kind of titration that I'll be teaching you would be KMNO4 titration, which is a self indicator. It would change its color on its own. Yeah? Okay. So the indicator that I'm talking about is the OG, not the Ruobza indicator, the phenolphthalein indicator. It's a weak acid. In acidic medium, it is unionized, and in basic medium, it is ionized. So this is something from where the question can arrive. Please check. This is the place from where the question can come also. You can check unionized is colorless, and the ionized part of the indicator. So these are indicator phenolphthalein is a weak acid. So it will become ionized in the basic medium. Okay, so this is how it is. Check this out. This is the structure of your phenolphthalein, colorless. This is colorless. But if you're providing, now look at the arrows. I'm going in this direction. So arrow when I'm going in this direction, if you're providing basic medium, check you're getting the ionized form, and there are two resonating structures here. Check all the structures now in one go. Correct? So if you observe this, the ionized form is pink in color, and that's exactly the defining moment for us, that what should be in the burette and what should be in the conical flask. So let's see now. Also methyl orange can be used, but the one which is mostly asked by the examiner in NEET as well as JEE is with the phenolphthalein, but you should be aware for the methyl orange also. Methyl orange is yellow in color in the basic medium, but it becomes, and it's a weak base, and it becomes acidic. In the acidic medium, it becomes red. Okay, so the one that I'm using in current acid-base titration is your, that's right, phenolphthalein. Cool. So aim is to determine the strength of sodium hydroxide solution by titrating it against the standard solution of the oxalic acid. Check the reaction oxalic acid the moment I say COOH, COOH. I hope you remember Ohm's gap, OMSGAP. So O comes at the top. So COOH, COOH with NaOH gives you CO minus Na plus and CO minus Na plus and water. So the procedure is you prepare the standard solution. That means you weigh oxalic acid in such a way that if you are adding it in 1 liter, there is a specific weight that you would have to find out. Tell me in the comments, for 1 liter, how much oxalic acid should you weigh to get a 0.1 molar solution? I'll be waiting for your comments. So after you've prepared 0.1 molar oxalic acid solution, you are going to add the sodium hydroxide in the burette, and you're going to pipette out 10 ml of oxalic acid. So you know the volume of oxalic acid already, right? You're going to add in the conical flask 1 to 2 drops of the phenolphthalein. So that now, do you understand what's happening? Say this is your burette. This is your conical flask. Inside the conical flask, you have 10 ml of oxalic acid whose concentration you already know as 0.1 molar. And here you do not know the molarity, but you would know the volume thanks to what is going to happen. So here you have a colorless liquid, or I should say colorless titrant. And the one that you are titrating, the concentration of whose is unknown. What you can do is you will keep on adding drop by drop by drop. So the moment there will be a basic medium, there will be a slight pink color observed, and that will fade off, that will disappear, because the overall pH is not basic yet. And only when overall pH is basic, you will have the pink color arriving, right? So you will see that, and you have to do it very slowly, very gradually, okay? You do not have to operate it like what you do in bathroom. Open the null and just forget about it. No. So it's not a tap, it's a burette. So with the burette, you have to be patient. You have to maintain your calm. It's a great meditative process in itself. Be a little patient. Do not be like, hey God, please give me patience, but hurry up. Don't be like that. Okay. So here we have the burette, may say, the NaOH solution is going to come out, drip slowly and gradually, and you will know that when you have to be extra careful, because you will see that 1-2 drops towards the equivalence point will take a while to disappear. So you have to keep swirling. Do not forget to keep swirling. Swirling, you understand that you have to keep rotating the conical flask, so that either there are stirrers which are already available, but in school I'm assuming that might not be present. So keep swirling on your own. Atmanirbhar. Okay. So when there will be equivalence point, the colorless solution will turn colored, pink in color, right? So you would know the volume at which the equivalence is happening, isn't it? So this volume can be known the moment you have achieved the equivalence point. So now you can use N1V1 is equal to N2V2. So you know that N1 is nothing but M1 V1 N factor 1 is equal to M2 V2 N factor 2. So let's say 1 is for NaOH and 2 is for oxalic acid. So can I say M1? We do not know. V1, say, and you have to do it thrice till the time you get a concurrent, not thrice, maybe more, but till the time you do not get concurrent reading. What is a concurrent reading? 2 consecutive readings should be same. So you have to wait for the concurrent reading, and let's say the concurrent reading was 5 ml. Okay, then N factor 1, because we are talking about NaOH, so you know that OH minus, there's just one OH minus, so N factor is 1. And for molarity of the oxalic acid, we already know the molarity, we already know the volume because we pipetted out 10 ml. And N factor is going to be 2 because there are 2 replaceable H plus. So from here you would know the molarity, and if you know the molarity, if you understand what's the relation between molarity and strength, I think you can easily do it. What is molarity? Number of moles per unit volume in liter. Number of moles per unit volume. But what is strength? It is gram per liter. So strength, if we talk about, basically if you multiply this by molecular mass, your molarity thingy with the molecular mass, you will end up getting strength. So that's what you have to do so that you can score marks and not what?
हाँ, गैस करो मेरे कितने आए होंगे. हिंट ये है कि तुम उंगलियों पे नहीं गिन सकते. मेरा आया था आधा नंबर. 100 में से आधा.
That's what you have to do so that you can score marks and not what he did. Yeah?
So now if you see, we have completed your chapter of practical organic chemistry, Titrimetric Analysis. Check it out. I have taken all of it in details. The titration error, indicator, molarity, primary standard, the acid-base titrations, the methyl orange thing, choice of indicator, theory. If you check out the entire stuff we have taken, the swirling I was telling you, look at this. I hope you're aware of what is a burette now. The burette had your sodium hydroxide and conical flask had oxalic acid, the standard solution with the phenolphthalein. So this is the table you're supposed to maintain till the time you do not get the concurrent reading. So I hope how to take the reading from the burette is clear, the starting point and the end point, and do always look at the lower meniscus in the cases of the colorless liquids. But when you have colored liquids, like when I'm going to talk about the redox titration, then the upper meniscus is to be taken because it's a colored liquid. Okay, you tell me in the comments, you do it in physics, why do we take lower meniscus for the colorless solutions and upper meniscus for the colored liquids? All right, so once you have it, you can easily find out the concentration, and you can also find out the strength. If you find out molarity, you just have to multiply it by the molecular mass and you are good to go. So keep the precautions in mind, and I hope this kind of a session really helped you with the practical organic chemistry. ये style आपको कैसा लगा? Taking help from the series, taking help from the different OTT content, movies, and studying chemistry. How is this idea? Do let me know in the comments. I hope you enjoyed. Do hit the like button and do not forget to save the video. Share it with your friends. See you tomorrow.